So let us discuss this concept, that is the potential energy diagram. Okay. Now before understanding what is potential energy diagram, we need to understand stable and unstable equilibrium. So what is stable equilibrium? First of all, what is stability? Let us take this case. You have a bowl, okay, and a ball. You release a ball inside this bowl. What do you will observe? You will observe that this ball will move to and fro inside this bowl, and after a while it will reach to the center of the bowl. Or you can say it will gain stability. Okay. So if this bowl was kept upside down and the ball was released at this point, then in this case you will see that a little disturbance and this ball will continuously fall below this bowl, which means it will not gain its stability. Okay, so that can be understood or visualized as stable and unstable equilibrium. Okay. Now so what do we know about potential energy? Okay, now we have already discussed that potential energy, okay, change in potential energy, okay, is nothing but negative of the work done by a conservative force. Okay, this is in a limiting case. Okay, this can also be written as if this is the conservative force, okay, then this can be written as FDS. Now this is the small displacement. You take this ds on the other side, then the differentiation of the potential energy with respect to the displacement is nothing but negative of the restoring force. Okay, now we will keep this equation for a while and we will be using this while discussing the potential energy diagram. So now what do you understand by the term restoring force? Okay, we will take a case of a spring. Okay, say for example we have a spring and you try to pull this string in this direction, which means that you are extending this spring further, okay, by some displacement change in x. Okay, now you know that there is a spring force that is developed such that which will try to restore this disturbance that is caused on the spring. Okay, spring force. So this force is nothing but the restoring force. Restoring force is something that tries to repel the disturbance caused on the system. So if there is a displacement in this direction, then the restoring force will act in the opposite direction. Now if there is a displacement in this direction, say for example this spring was compressed, then the restoring force will act in the opposite direction still. Okay, the restoring force will act on this direction. Okay, we have understood what is restoring force. So let us understand the diagram now. Stable equilibrium. Stable equilibrium diagram. Okay, now I have already discussed the visualization of the stable equilibrium by taking a case of a bowl and a ball. Now let us take the diagram, or is similar to that. You have on the x-axis the displacement, okay, that is the change in x. On the y-axis you have the potential energy. Now the diagram is like this. Okay, now So you can see in this diagram the curve, that is, this curve has a positive slope on this side and a negative slope on this side, and at the center you have zero slope. So what is the slope I am talking about? The slope is nothing but between the potential energy and the displacement. Okay, this is the slope, which is du by dx. Okay, potential energy can be represented by u. So this slope is positive. Okay, slope is positive in this side, which is negative at this other side, and on the center slope is equal to 0. Okay, now let us analyze for the case when the slope is positive. So when du by dx is positive, du by dx is nothing but negative of the conservative force. Okay, or in this case you can say it is nothing but the restoring force. The slope is positive, which means the force that we are getting here is negative. Okay, and also we can see that when x is increasing on this side, when x is increasing, then the potential energy is also increasing. What does that mean is the slope is positive. Okay, both side is positive, so slope is positive. We have already discussed the concept of restoring force. When change in x is positive, okay, is positive, then the restoring force would be negative. So which means that this has a restoring effect. This force here has a restoring effect, and it will try to bring that system to a stable equilibrium. Okay, now if you see on the other side here, when slope is negative, okay, this change in x here is positive. Okay, when change in x is decreasing, then potential energy increasing, which means this is negative and this is positive, so the overall slope is coming out to be negative. When slope is negative, we know that du by dx is negative of f, so this is negative, so du by dx is equal to negative f, so the force here is coming out to be positive this side. Okay, now you can see that when on this side, when change in x is negative, when change in x is decreasing, the force is coming out to be positive, which means we have already discussed here, when change in x is decreasing, the force is coming out to be positive. So this also has a restoring effect. It will try to bring the system, this force will try to bring the system to a stable condition. So this case would be for the stable equilibrium. Now for the last one, we can see that when du by dx is equal to 0 at the center position, okay, du by dx is nothing but negative of f, the force is coming out to be 0. So when the slope is 0, in that condition the force is 0, which means there is no change in the system. The system is already on equilibrium. So this is nothing but the equilibrium state. Okay, this is equilibrium state. This is restoring state. This is also restoring. So this was the diagram for the stable equilibrium. We're going to discuss for the unstable equilibrium. Okay, unstable equilibrium diagram. So I have already demonstrated what is unstable equilibrium by using the concept of that bowl and a ball. The diagram is similar to a ball in an upside down direction, and this is change in x, this is potential energy. Okay, you can see that this side has a negative slope, this side has a positive slope, and this side has zero slope. Okay, so in this situation you can determine as previous one, when the slope is negative. Okay, when the slope is negative, here you can see du by dx is negative. Then what is happening? Du by dx is nothing but negative of the force, restoring force. This is negative. Okay, so the force is overall coming out to be positive. Okay, which means when x is positive in this direction, this is positive x, the force is also coming out to be positive. So this has an unstable nature. When you are trying to disturb the system in the positive direction, the force is acting on the same direction of that disturbance, which means the system will try to be unstable. And on the other side, if you see, the slope is positive. Okay, slope is positive, which means that the force will come out to be negative. Now on this side, when change in x is decreasing or it's negative, the force is also coming out to be negative, which means there is no restoring effect. The direction where the displacement is occurring, the same direction the force is acting. So this is an case of an unstable equilibrium. Now there is another type of the equilibrium diagram, that is the neutral equilibrium diagram, where the line is straight. Okay, in this case you are applying a force in this direction, the body will move in this direction, and if the displacement is in this direction, other direction, the force will also act on the other direction. So what is the difference between these three type of equilibrium? In case of unstable equilibrium, you can see easily that when you are applying a slight disturbance, slight displacement in this direction, the force will continuously try to act on the same direction, and the system is very unstable. Okay, in case of stability, the direction where the displacement is occurring, the force is acting in the opposite direction, such that the body is trying to bring the system in the stable condition. Okay, and in the case of the neutral equilibrium, when a slight force is acting on this direction, the body will slightly get displaced on the same direction, but it will not continue to be displaced on the same direction as in case of the unstable equilibrium. Okay, that is the main difference between these three types of equilibrium.